Hello students, welcome to my YouTube channel. I am Biot-savart. From today, I am going to start our new topic, electromagnetism. What is electromagnetism? You know that when current passes through a wire, then a magnetic field is induced around the wire. If a magnet is brought near to the wire, then the magnet is repelled or attracted. On the other hand, when current is passes through the wire, if a powerful magnet is brought near to the wire, then the wire is also deflected. This phenomena is known as electromagnetism. That is, the interaction between the electric field and magnetic field is known as electromagnetism. Now, our subtopic is Biot-savart law or Laplace law. From this law, Biot-savart law or Laplace law, we can measure the magnitude and direction of the induced magnetic field produced by the electric current passes through a wire. This is a wire and I current passes through this wire. O is a point on this wire. DL is a small length. DL is the small length of the wire. T is the tangent drawn to the wire at the point O. PB another point outside the wire. OP is R. We are to find out the induced magnetic field at the point P due to the current flow of I of the small line segment of the wire DL. Let us consider the induced magnetic field is dB, is produced due to the small line segment DL of the wire. In electromagnetism chapter, we can denote the direction of dB or induced magnetic field by two notations. This notation indicates that outward normal vector or outward normal magnetic field. That is, the magnetic field is normal to the paper and it in outward direction. Okay, to the normal to the paper. This sign denotes the inward normal vector, that is induced magnetic field is normal to the plane of the paper and inward direction. Okay, now from Biot-savart law we can write, you know that when the magnitude of current increases, then the magnitude of the induced magnetic field also increases. That's why we can write mod of dB is directly proportional to I. Okay. Next, you know that the effect of induced magnetic field is, or effect of the induced magnetic field is very feeble with the long distance. That's why we can write that magnitude of dB is inversely proportional to 1 by r square. That is, when the distance increases, then the magnitude of induced magnetic field also decreases to the square of the distance. Third, mod of dB, that is magnitude of dB is directly proportional to sine theta. Well, theta is the angle between T and R, T vector and R vector. Okay, dB is proportional to sine theta. And last, the magnitude of dB is directly proportional to dl. That is, magnitude of induced magnetic field is directly proportional to the length of the wire. Clear? From the above four relations, we can write that magnitude of dB is directly proportional to I dl sine theta by r square, or magnitude of dB is equal to mu 0 by 4 pi I dl sin theta by r square. You know that when we write equal sign instead of proportional sign, then we have to introduce some constant. Here the proportionality constant is mu 0 by 4 pi. This law or this relation holds good in SI system in air. This law is for SI system in air. Okay. This is known as Biot-savart law or Laplace law. You know that the induced magnetic field is a vector quantity. That's why we have to write the vector notation or vector form of dB. Clear? You know that in this formula sin theta presents. That's why the cross product must be applied. Therefore, we can write the vector form of dB as dB is equal to mu 0 by 4 pi dl cross r cap by r square. Here r cap is the unit vector of r vector and r denotes the magnitude of r vector. Therefore, you know that r cap is equal to r vector by magnitude of a mod of r vector. Then we can write dB vector is equal to mu 0 by 4 pi dl cross r vector dl vector cross r vector by mod of r cube. This is the vector form of Laplace law or Biot-savart law. Okay. For large portion of the wire, if we consider the large portion of the wire, then we have to integrate the last expression. That's why for the large portion of the wire, the induced magnetic field at the point P, we can write B vector is equal to mu 0 by 4 pi close integration of dl cross dl vector cross r vector by r cube. Okay. You already know that the Maxwell right hand corkscrew rule or Maxwell right hand rules that applying in cross product, the direction of r is such that the inward to the normal vector, dB is the inward normal vector to the paper or board, to the plane of the board. That's why the dB can be denoted as, direction of dB can be denoted as cross. Okay. This is the total expression or whole expression of Biot-savart law or Laplace law. Now I shall discuss about the application of Biot-savart law or Laplace laws. First topic is determination of induced magnetic field due to a straight current carrying conductor at the point P. Let y prime is a straight current carrying conductor and capital I be the current flowing through this wire from y prime to y direction, that is along the positive y axis. Okay. P be a point on the outside of the wire and OP is equal to R. OP is equal to R vector while OP is normal to the wire. Y prime is normal to OP. Okay. OP is equal to R. Let small a be a point on the wire and AP is equal to X. AP is equal to X. Okay. We have to find out the induced magnetic field at the point P due to the line segment BC. Okay. Let AO is equal to L. Let AO is equal to L and DL be a small portion of the wire at the point A. At first, we have to find out the magnitude of dB, which is the induced magnetic field at the point P due to the small line segment dl at the point A. Then we can integrate the expression of dl for the line segment BC. Then we shall find out the vector form or magnitude of dB or of the induced magnetic field at the point P. Let's see the video to determine the induced magnetic field at the point P due to the line segment BC. In this figure, angle YAP is equal to theta. Angle YAP is equal to theta. That's why angle OAP is equal to pi minus theta. Angle COP is equal to 90 degree. Okay, because the OP is normal to y prime axis. And angle OCP is equal to theta 1. Angle YBP is equal to theta 2. Now, the induced magnetic field at the point P is due to the small portion of the wire dl at A is magnitude of dB is equal to mu 0 by 4 pi I dl sin theta by r square. It can be written from the Biot-savart law. Now, from the triangle AOP, you can write that r by x is equal to r by x, that is normal by hypotenuse, is equal to sine pi minus theta. This angle is pi minus theta, that is OAP is equal to pi minus theta. You know that sine pi minus theta is equal to sine theta. That's why we can write that x is equal to r cosec theta. Okay. Again, from the triangle AOP, we can write r by l, that is normal by base, is equal to tan pi minus theta. You know that tan pi minus theta is equal to minus tan theta. Therefore, we can write L is equal to minus r cos theta. Okay. Differentiating both sides, we can write that dl is equal to r cosec square theta d theta. Okay. Now we can write the Biot-savart law the following form, or we can substitute the values of dl and x in the above equation, that is in the Biot-savart equation. We can write mod of dB is equal to mu 0 by 4 pi r cosec square theta I sin theta d theta whole divided by r square cosec square theta. Because you know that dl is equal to how much? dl is equal to r cosec square theta d theta and x is equal to r cosec theta. Therefore, x square is equal to r square cosec square theta. Now, cosec square theta becomes cosec square theta by cosec square theta becomes 1 and r by r square becomes r. Therefore, we can write mod of dB is equal to mu 0 by 4 pi I sin theta by r d theta. Okay. This is the magnitude of induced magnetic field at the point P due to the small portion dl of the wire. Now we can integrate easily this expression to find out the induced magnetic field for the whole wire or the for the portion of the wire BC. Therefore, mod of B is equal to mu 0 by 4 pi I by r integration of theta 1 to theta 2 sin theta d theta. Here theta 1 is the lower limit and theta 2 is the upper limit. You know that integration of sin theta is equal to minus cos theta. Therefore, we can reverse the limiting value of the integration. Then we can write mod of B is equal to mu 0 by 4 pi I by r cos theta into theta 2 to theta 1. Therefore, mod of B is equal to mu 0 by 4 pi I by r cos theta 1 minus cos theta 2. This is the final expression for the induced magnetic field of the straight current carrying conductor BC at the point B. This is the final expression of the induced magnetic field. Okay. Now you know that the direction of the induced magnetic field B is inward to the plane of the paper. When the wire is infinitely extended, then theta 1 tends to 0 and theta 2 tends to pi. Okay. Therefore, for the infinitely extended wire, the induced magnetic field at the point P due to the induced infinitely extended wire is becomes mod of B is equal to mu 0 by 4 pi I by R cos 0 minus cos pi. This gives mod of B is equal to mu 0 by 4 pi 2I by R. I think you understand this topic. If you have any question, then please write your question or queries in my comment box related to this topic. Now I shall going to determine the induced magnetic field at the center of the current carrying circular loop. Okay. Let this is a current carrying circular loop. I amount of current is passes through the circular loop in anti-clockwise direction. Okay. R be the radius of the loop and A be a point on the circumference of the circle. dl is a small portion of the wire or of the loop. Now applying Biot-savart law, we can say that induced magnetic field at the center of the circle, that is magnitude of B, is equal to closed integration of mu 0 by 4 pi I sin 90 degree dl by r square. Since the angle between r and the tangent of the circle at the point A is 90 degree, that's why we can write sin 90 degree instead of with in the place of sin theta. Okay, sin 90 degree in the place of sin theta. Here mu 0 by 4 pi is constant, I is constant and r is constant. You know that the radius of the circle is constant. That's why we can integrate only dl. This is a closed integration because this is a closed loop. Now you know that closed integration of dl is equal to the circumference of the circle. Therefore, closed integration of dl is equal to 2 pi into r, which is equal to the circumference of the circle. Therefore, mod of B is equal to mu 0 by 4 pi 2 pi I by r. And you also know that the unit of magnetic induction or magnetic induced field, that is B vector, is Tesla in SI system. That is unit of B is Tesla in SI system. And now the direction of B vector. When the current flowing through the loop, circular loop, in anti-clockwise direction, then the direction, the induced pole is north pole. And when the current flows in clockwise direction, then the direction of the current is south pole. Okay, when current flowing in clockwise direction, then this is south pole, induced south pole, and when the current flows in anti-clockwise direction, then this is north pole, induced north pole. Okay, that's why in this case the current flows in anti-clockwise direction, therefore it is the north pole. Okay, and the opposite side of the circular loop is induced south pole. And for n number of turns, the number of turns are to be multiplied by this expression. That is, for n number of turns, the magnitude of B becomes mu 0 by 4 pi 2 pi ni by r, ni by r, where n is the number of turns of the circular loop. and radius of every turn becomes r. Let A be the curvature or small segment of a circle having radius r. O be the center of the circle. I amount of current is passing through the curvature AB, okay, or arc AB. Now the induced magnetic field at the center of the curvature, that is O, at the point O, is magnitude of B is equal to mu 0 by 4 pi theta I by r. This expression you can derive from the by the similar ways I have shown it earlier portions, or in the previous time. Okay. Therefore, by theta is expressed in radian unit. Yeah, theta is expressed in radian unit, not in degree unit. Okay. For n number of turns, you can write the magnitude of B vector is equal to mu 0 by 4 pi theta I n by r. This is the more or less complete discussion about Biot-savart law or Laplace law. I think you can understand this topic. If you have any questions related to this topic, then please write your questions or queries in my comment box, and please tell me about the videos and about your understanding or interaction with me through these videos. Okay, and if you any suggestion to prepare better videos for you, then please write those in my comment box. Okay, these videos only for you, and please interact you with me through videos or through YouTube. And thank you for watching my video. Have a good day.